Hey you guys, welcome back as we continue to talk about the normal distribution. Now, you've probably spent a good bit of time calculating probabilities from standard normals and non-standard normals, from x's and z's. And for the next few minutes, I'd like to explain to you the relationship between these two distributions. They are both normal distributions, but it turns out that any question that you could answer in terms of a non-standard distribution can be rephrased, can be standardized, and then answered in terms of a standard normal distribution. You can actually flip back and forth between these two. Now, way back in the day, we used to have to do that because you had to get your probability answers from a table, and there was only one table. It was for the standard normal. These days, you don't quite need to do that to answer probability questions, but you do need to learn this technique because it's going to come up many times. In fact, every time that you're going to do a hypothesis test. So you might want to test some hypothesis that the true population is a certain thing, and converting to a standard normal is going to be like your bread and butter. So with that said, let's see how it's done where we can convert between x's and z's. Okay, so here in front of you, you've got two normal distributions. You've got one that's written in terms of x. It happens to have a mean of 300. And then here on the bottom, we've got a standard normal, a z variable. You can see it's got a mean of 0. All right. So in fact, this guy here is standard normal, so it's got a mean of 0 and a standard deviation of 1. This guy up here is a non-standard normal. It has a mean of 300 and a standard deviation of 50. And you might want to know, what is the probability that x is less than 325? So we label 325 right there. And what we want to know then is, what is this entire area here? So we want to know that probability. Now we can do this in Excel, but let's see how we can use convert to a standard normal and then use Excel. So the thing to notice is that 50 is the standard deviation. So when we go from 300 to 325, we're actually going up by a half of a standard deviation. In terms of a z variable, that would mean that we're going up to a z of a half. And then this probability is actually what we're interested in. So what did we do here? We had this question. What is the probability that x is less than 325? So let's just focus on this part. Now we can subtract off whatever we want as long as we do it from both sides. So what if we subtract off 300? We're subtracting off the mean here of that x variable. Well, if you do it on the right-hand side, then we need to do it on the left-hand side too. So let's do that on a new line. X minus 300, 325 minus 300. Okay, so that simplifies. We can also divide both sides by something. And if we're not dividing by a negative, then we keep that arrow, that inequality, going in the same direction. So let's divide both sides by the standard deviation of 50. So x minus 300 over 50 is less than 25 over 50. Now 25 over 50 is just a half. And then what is this when we have x and we subtract off the mean and divide by the standard deviation? That's our formula for standardizing a variable. whenever we were doing the z-scores. So we can see that we've converted this statement, x less than 325, to this statement, z being less than a half. So what is the probability that x is less than 325? It's got to be the same as the probability that z is less than a half. And now we can use Excel to answer that question. Let's do that real quick. So what is the probability that z is less than 50? So norm.s for standard, dot dist, and we just give it our probability and put true for cumulative. And we get 69%. Now, is that really the same thing as if we had done this directly in terms of x's? Now we do norm dist, not s dist. We put in a particular value for x, the mean and standard deviation of the distribution we're actually interested in, and then put in true. And we get the same exact thing. So as you can see from algebra and from Excel, questions about x's can be phrased in terms of z's, and you can actually go back and forth. Let's do one more example. So in this example, we've got a random variable, x. It's distributed normally, but not standard normally. So it's got a mean of 100 and a standard deviation of 16. IQ follows this general pattern. Now, let's say that the question is, if you were to pick a random person, what's the probability that they'd have an IQ less than 116? Now, this question is phrased in terms of x's, but we'd like to answer it in terms of z's. So I'd like to map from one to the other. So first, let's just draw what we're doing. In our original question with x's, we want to know what is the probability to the left of 116. So we want to know what this probability is. What is the probability that x is less than 116? Now, how can we answer this in terms of z's? We're going to follow the same procedure as before. X less than 116 is a valid algebraic expression, and we can modify it just as long as we do, that modification to both sides of the inequality. So we can subtract off anything from both sides. So we could subtract off 100. So that leaves us with 16. And then we can divide by any number. We could divide by this number, the standard deviation. 16 divided by 16 is just 1. And then what is this? We took an x variable, subtract off its mean divided by its standard deviation. So that is now a z. So this statement, what is the probability that x is less than 116, is equivalent to this statement. What is the probability that z is less than 1? We can see if we draw the z distribution, these probabilities look the same. Now let's verify that in Excel. So we said that we could rephrase our question about x's in terms of z's. Specifically, what's the probability that z is less than 1? So let's do that. Let's calculate that. We're asking about a normally distributed variable. It's a standard normal, so we put the s there. And then we just tell it the particular value of z that we're interested in. Then put true, close the parentheses, and hit enter. And we get 84%. Now, would we have gotten the same thing had we not done the translation from x to z? Like, what if we had just done x calculation? So we still do norm. Now we do dist because it's not standard normal. We enter our particular value of x, the mean and standard deviation that we're pulling from, and then true for cumulative because we want the area all the way, to the left of 116. We hit enter, and we get exactly the same number. We get 84%. Okay, so 84% is either this area or that area. They're both the same number. We had a question about x's, but we can answer it just using standard normals. All right, that's it for now. Thanks for listening.